Welcome to this video. And in this video, we look at the proportional plus integral plus derivative controllers, PID controllers. The proportional plus integral plus derivative controllers. We have so far looked at the proportional plus integral, and the proportional plus derivative controllers. And we are able to analyze their performance given certain systems. The control signal for the PID controller will be partially proportional, partially an integral, and partially a derivative of the error signal, and mathematically will be defined by U of t is equal to Kp E of t plus Ki, the integral of E of t dt, plus Kd d dt of E of t. If we take the Laplace transform, we will obtain U of s to be equal to E of s into Kp plus Ki over s plus skd, from which our controller will be defined by U of s over E of s is equals to Kp plus Ki over s plus skd, which can be written as, under common LCM, we'll have s, then s squared kd plus skp plus ki, if we are to write it in a polynomial in descending powers of s. From these, it's good to notice that the controller is going to add two zeros, to the system, and is also going to add a pole at the origin. So if we introduce a PID controller, because the numerator is a second order polynomial in S, means additional of two zeros, and then the denominator is S, that means introduction of a pole at the origin of the S-plane. Now, it's also good to note that the system will be increased, or the type of system will be increased by 1. The type of system will be increased by 1. So the type of the system will be increased by 1. Now, when we bring in the PID controller, we would want to tap in the benefits or the best properties of the PI and the PD controller. And in particular, we noted that for the PI, we are able to achieve steady state performance. So with PI, we are able to achieve a steady state performance. And with PI, again, we are able to bring in the aspect of design, independence in design for zeta and omega n. So able to bring about the independence in design for zeta and omega n using the PI. For the PD, we are able to bring issues to do with reduced overshoots, setting time, So we are able to reduce the overshoots and the settling time. In other words, we make the system to respond faster, and we are able to sort about issues on stability. So in a PID, we would want to tap the benefits of a PI and a PD and come up with a better controller. In so doing, we notice that the only disadvantage would have is that for the PID would require more components. And of course, that would mean the system or the controller may become expensive. And the only disadvantage that would try to overcome is the cost of meeting the given controller as a PID controller. Now, also notice that our given controller is defined by S squared KD plus SKP plus KI over S. The choice of the proportional gain Kp, integral gain Ki, and derivative gain Kd, so as to have the best controller would be of importance. And therefore, the process of choosing the best values of the proportional, the integral, and the derivative gain constants become important while designing the PID controller. And the process of choosing the best values for the gains is going to follow a scientific process, and that process is called tuning of the PID. So the process of choosing the PID gains so as to come up or to meet the given design specifications is referred to as tuning of the PIDs, and this will be my next point of discussion in my next video. Otherwise, we would expect that in the PID controller, we would come up with a controller that is able to tap the benefits of the PI, namely improved steady-state performance and the independence in design on the damping factor and the natural frequency of oscillation with the introduction of the PI. And number two, with the PD, would have reduced overshoots and reduced settling time, as well as an improvement on the stability of the given system. The only challenge that would have to overcome is the cost of meeting the controller, since the PID would require more components, and therefore it's expected that the controller may become expensive. Otherwise, that is the end of my discussion on the PID controllers. And in my next video, I will embark on tuning of the PID controllers. Thank you for watching my video.